Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. My name is Ms. Hind Abbas, and we will revise science together. Okay, let's start with lesson 1. Unit 1, lesson 1, matter and its characteristics. Any matter has properties. Those properties, chemical properties and physical properties. Physical properties like what? Physical properties, color, taste, smell, density, melting point, boiling point, hardness, electric conduction, and thermal conduction. What about the physical properties? We will revise the activity of metals. Okay, first, density. What is density? Let's look at those two cubes. We have here cube A and we have cube B. Which one has more density? Sure, cube B has more density. So what is density? Density is the mass of unit volume, and density is a fingerprint for the substance. Each substance has a fixed value of density. Now, let's make this calculation, this very easy calculation. Okay, first we have a measuring cylinder, and here in this measuring cylinder, we have 30 cubic centimeters of water. When we add this rock, the water level increases to 40 cubic centimeters. Okay, so here in this problem also, he mentioned the mass of the rock. So we wanted to calculate the density of the rock. Okay, density. Yes, okay, the density of the rock, as we know, density of the rock equals the mass of this rock divided by the volume of this rock. We have the mass of this rock. Where is the mass? Yeah, here is 50 grams. 50 grams. What about the volume? We don't have the volume of the rock. We have the volume of water before and after adding the rock. So the volume of the rock is the difference between those two volumes. So V of the rock equals V2, which is this water level, minus V1, which is before adding the rock, which equals to 40 minus 30 equals 10 what? 10 cubic centimeters. Okay, so here we will put the volume, which is 10 cubic centimeters. So the density of the rock equals the mass of the rock divided by the volume of the rock, which equals to 5 what? Gram per cubic centimeters. Okay, this is the density of this rock. All of the density calculations are very easy. Okay, what or think? Okay, so here guys, in this one, we have an iron nail, and we put this iron nail in this container, and this container contains water. Then we removed the water and we add mercury. So tell me, the iron nail will float or sink, and why? Okay, so let's see this one. If here is the water, and if we add the iron nail, what will happen? Yes, it sinks. Oh, wow. If we change it, the water with mercury, and we add the iron nail, so it will float. Why? Okay, so let's check those numbers. Here we have the density of water, which is 1 gram per cubic centimeters. Okay, and this is the density of iron. Which one has higher density? Yeah, sure, iron has higher density than water, so it will sink in water. So iron sinks in water. Okay, what about with what about this iron nail if we put it in mercury? Yeah, let's see. Yes, this is the iron. Okay, this is the iron density, and this is the mercury density. Oh, which one that has higher density? Mercury. So mercury will sink and the iron will float. So iron nail, it floats on the in mercury. Okay, in mercury. It's why? Because it has it has lower density than mercury. Yes, 77.8 is less than 13.5. So less density, so it will float. It will move upward. Okay, so again, the iron nail, it will sink in water while it floats in mercury. Why? Because the density of iron is higher than the density of water, while the density of iron is less than the density of mercury. Okay, why water doesn't put out petrol? Why, if we have petrol here, yet and we add water, it will not put off this fire? Why? Because the petrol, it has less density than water, so the petrol will float on the water surface, so we can't extinguish the the petrol fires by using water. Why? The balloons festivals are filled with hydrogen or helium. Why? Because hydrogen and helium, they have lower density than water, so they will move upward. Lower density, move upward, while higher density, it will sink. Okay. The second fingerprint for the substances is the melting point. Each substance has a definite or a fixed value of the melting point. What is melting point? First, melting, it's the changing from the solid state to the liquid state. What is melting point? So it's the temperature at which the matter changes from the solid state to the liquid state. And the melting point of ice is 0 degrees Celsius. So at 0 degrees Celsius, the ice will change from the solid state to the liquid state. We divide the substances according to their melting points into two types. Low melting point, like wax, butter, and ice. And there are some substances that have high melting points, like metals, also table salt. Okay, give reason why the workmen, they melt the solid metals. Why? Why they need to melt them? To reshape them to make what? To make alloys. Like what? Like the copper gold alloy to make jewels, and like the nickel chrome alloy to make heating coils. This is the heating coils. Okay. Boiling point. This is a fingerprint also for the substance. Boiling. What is boiling? Changing from liquid to gas. Okay, so what is the boiling point? So it's the temperature at which the matter starts to change from the liquid state to the gaseous state. And here, as we said, it's a fingerprint for the substance. What's the boiling point of water? It's 100 degrees Celsius. Okay, and here we have a live application about the boiling point. The separation of the components of the crude petroleum oil by heating. Why? Because the petrol, it has a lot of components, okay? These components, they heat the petrol, okay? So some components, when they reach their boiling point, they will evaporate, okay? Evaporate, change from liquid to gas. So we can separate it, then raise the temperature. Another component will reach its boiling point. Then, so change from liquid to gas, then separate. Then again, repeat. Liquid to gas separate, liquid to gas separate, liquid to gas separate. So this is the separation of the components of the crude oil. It depends on what? Melting point? No, it depends on the boiling points, because they have different boiling points, because the boiling point is a fingerprint for the substance. Okay, let's see the hardness. There are some substances that are soft at room temperature, like what? Like rubber. There are some substances that have to be heated to soften them, so we can reshape them, like all of the metals. There are some substances that can't be softened by heating. They will change into powder. We can soften them. We can't change them into liquid. Like what? Like sulfur and coal. Okay. Why the roads that's used in building concrete houses are made up of iron and not copper? Why? Why we made these roads by using iron, not copper? Because iron is harder than copper, so it's more safe to use them in the buildings. Okay, electric conduction. We have two groups here. There are some substances that are good conductors, others are bad conductors. Good conductors like what? Like metals, like acidic solution, alkaline solution, and salty solutions. What about the bad conductors? Yes, like what? Like the air, the gases, sulfur, phosphorus, plastic, wood, all of these are bad conductors. Also, there are some solutions that are bad conductors, like what? Like hydrogen chloride in benzene and sugary solution. So here, guys, yes, take care. Here is acidic solution, like if we have HCl, okay, hydrogen chloride. Okay, hydrogen chloride, when you add hydrogen chloride to water, so it's a good conductor of electricity. Why? Because it's an acidic solution, okay? It's a hydrochloric acid. But if we add the hydrogen chloride to benzene, it's bad conductor. So don't say hydrogen chloride is good or bad. Hydrogen chloride is bad conductor here only. No, you have to mention hydrogen chloride in benzene, it's bad conductor. Here the salty solution good, but the sugary solution is bad. Bad, it means don't let the electricity to flow through them. Okay. Why does the lamp A, here we have two circuits, okay, A and B. Why does only lamp A illuminate? Why? Because here, what is this is, yes, salty solution. And salty solution is a good conductor of electricity. While here, this is sugar in water. So sugary solution, it's a bad conductor of electricity. So lamp A will illuminate, while B will not illuminate. Why the electric wires are made up of aluminum? Here's the electric wires are made up of aluminum or copper, and it covered by a plastic material. Here, take care, you have to talk about to give reason for both. Yeah, why the electric wires made up of copper? Yes, because copper is a good conductor of electricity. Why it is covered by a plastic? Because plastic is a bad conductor of electricity. Okay, about the thermal conduction, again, the substances are divided into two types. Good conductors or bad conductors. Good conductors, they let the heat to flow through them. Like what? Like the metals. And there are bad conductors like what? Wood and plastic. Okay. Okay, yeah, here, why? Cooking pans are made up of aluminum or stainless steel, and their handle is made up of wood and plastic. So again, two parts here. This question in two parts. First here, this pan, it's made up of aluminum. Why? Because aluminum is a good conductor of heat. Okay, so it will let your food to be cooked. Okay, okay. So here it's a good conductor of heat. Only that, no, also aluminum, it has high melting point. So because of those two reasons, good conductor and has high melting point. If it has low melting point, so you will eat the pan while you are eating, yeah? Okay, and what about its handle? Its handle is a bad conductor of heat. Why? Because it's made up of wood or plastic. Okay, according to the chemical activities, we divide the metals into three groups. Very active metals like sodium and potassium. Sodium and potassium, we keep them under kerosene surface. Why? To prevent the reaction with the atmospheric air. See this piece of sodium? When you just leave it in the air, it reacts very fast with the oxygen in the air. So to prevent its reaction, we cover it by kerosene. Less active metals like iron, aluminum, and copper, we spray on them grease. Why? We spray on them grease to prevent the rusting and corrosion. Okay, because they will react with the oxygen and will form a layer of rust. So to prevent this layer, the formation of this layer of rust, just spray some grease on them, okay? Or you can wax them, okay? And for this one, yeah, do you remember Matem? Yes, we have to paint Matem, okay? Because it rusted. Okay, yeah, inactive metals like what? Like silver, platinum, nickel, gold, and chromium. Those are inactive metals. Okay, we use them in making jewels. Why? Because they keep their metallic luster for long time. Let's go to the next lesson. Yeah, like that, we finished lesson one. Okay, let's go to the second lesson. Yes, matter construction. Okay, the molecule, it's the smallest part of the matter which can exist freely, and it has all of the properties of matter. By the way, this video, yes, there are a lot of particles inside it. Yes, each particle here represents a molecule. Okay, so what is the molecule? It's the smallest part of the matter, and it can exist freely. It has all of the properties of matter. So the perfume consists of perfume molecules, and each perfume molecule, it has the properties of perfume, okay? Okay, let's see the properties of the molecules. All of the molecules are in continuous motion. All of the molecules, they have intermolecular spaces between these molecules, and there are some attraction forces between the molecules. So there are intermolecular spaces between the molecules, and there are attraction forces between the molecules. Why? When we add a drop of ink in this container, all of the container, its color will change into the ink color. Why? Because the ink molecules spread everywhere. It's in continuous motion. So it will spread everywhere among the water or among the liquid that is here in this container. Give reason why the volume of a mixture of water and alcohol is less than their sum together, the sum of their volumes together. Okay, how, teacher? Okay, so let's imagine here, guys. Yes, if we have 100 cubic centimeters of water, and if we have 100 cubic centimeter of alcohol, okay, of alcohol, and we add them together in the same container. So you expect that 100 plus 100, so they will be 200. No, the net volume will be less than 200. Why less than? Because some of the alcohol molecules enter between the inner molecular spaces, enter in the intermolecular spaces, or occupy the intermolecular spaces among the water molecules. Okay, why it's easy to divide water into portions? If you have a container of water and you can pour this water easily into a lot of cups. Why? Why? Because water is what? Water is liquid. And what about the attraction force between the liquid molecules? Yeah, weak attraction forces between the molecules, so you can divide it easily. Yeah, but can you easily divide a piece of iron into pieces? No, no, no. Why? Because iron is solid. So its particles there are inter-attraction forces. The attraction forces between its molecules are very strong attraction forces. So you can separate them easily, okay? Here's the comparison between solid, liquid, and gas. Okay, let's see. The motion of the molecules of solids, yeah, vibrational motion, limited motion. But the motion of liquid is more free. The motion of gas, completely free, freedom here in the gas. What about with the intermolecular spaces? Yeah, here's narrow intermolecular spaces, but relatively large between the liquid molecules and very large between the gas molecules. What about with the intermolecular forces? Intermolecular forces, yes, the force between the solid molecules, very strong forces. But with the liquids, relatively weak forces, and for the gas, vanished or very weak or not existed. The intermolecular forces are not exist. Okay. Okay, let's talk about the volume and the shape. The solid, it has fixed volume, fixed shape. But what about the liquid? It has definite volume and indefinite shape. How this one? Okay, so let's explain it. Okay, if you have here, if this is the cup, okay, and you have in this cup, you have water here, okay, and you poured 100 cubic centimeter of water, and you pour this water into another flask, okay, or another container. So the water will take the shape of the container. It will take the shape of it, okay? So does it have definite shape? No, so it has indefinite shape, okay, unfixed shape. So it's not, it doesn't have a fixed shape. Okay, what about with the volume? Does the volume change here? It was 100 cubic centimeters. If we put it to another container, oh, this volume, will it change? No, it will still 100 cubic centimeters. So it has definite volume, but its shape, it changes. It takes the shape of the container. Sure, the gas, indefinite volume and indefinite shape. Let's take some examples here. Ice, iron, and here oil, alcohol, and for the gas, oxygen, and water vapor. Okay. The molecules of the same substance are alike to each other. They are alike, they are similar to each other. Okay, this is a substance, this is another substance, this is another substance. Okay, so the molecules of the same substance, they are alike to each other, This one like this one like this one, and so on. Okay, but the molecules of different substances, they are different from each other. Look at this molecule and look at this molecule. Yeah, sure, they are different from each other. And that molecule, it consists of smaller units called what? Called atoms. So here for this molecule, it consists of 2 atoms. Yeah. Okay. So what is the atom? The atom is the fundamental building unit, fundamental building unit of matter. Fundamental building unit. This is the atom. But what is the molecule? Molecule is the building unit without the word fundamental. Fundamental is related to the atom. Okay, and also the atom has another definition, which is it's the small individual unit of the matter which can share in chemical reactions. Okay, but for molecules, it's the small small part of the matter which can exist freely, and it has all of the properties of the matter. Okay, let's clean our board. Okay. What are the kinds of molecules? We have two types of molecules, element molecule or compound molecule. Element molecule, what is element first? It's the simplest pure form of the matter, which can't be analyzed chemically into simpler form by the simple chemical methods. Element, so here in the element molecule, yeah, we have two types, monoatomic or diatomic. Monoatomic, so mono, it means one, so the molecule consists of only one atom. If it is in the liquid state, we have only one example, which is mercury. If it is in the gas state, so we talk about the noble gases, helium, neon, argon, krypton, xenon, radon. All of the noble gases, their molecules consist of one atom. Each molecule consists of one atom. What about the diatomic molecule? Diatomic molecule, they look like twins together, twins. Okay. Diatomic molecule, we divide them into two parts. That if it is liquid, so it's a bromine. Bromine is the only diatomic liquid element. What about if it is in the gaseous state? If it is in the gaseous state, so all of the active gases here. This is hydrogen, nitrogen, chlorine, oxygen, fluorine. Okay, so those are the active gases or diatomic molecules, but the noble gases, they are monoatomic molecules. Okay, what about the compound? Compound is a substance which is formed from a combination of two or more different elements with constant weight ratio. This is the hydrogen chloride molecule. Hydrogen chloride, it consists of two atoms, hydrogen and chlorine. Yeah, two atoms. Remember here, two atoms of how many elements? Two atoms of how many elements? Yeah, two elements. What are those two elements? Yes, hydrogen element and chlorine element. What about the next one, which is the water? Water is a compound molecule. Why? Because it consists of different types of elements. Yeah, it consists of one oxygen atom and how many hydrogen atoms? Two hydrogen atoms. So how many atoms? Yeah, three atoms. Three atoms of how many elements? Of two elements, which are the oxygen and the hydrogen. Okay, let's go to the third one, which is ammonia. Ammonia molecule. Ammonia molecule consists of how many atoms? Wow. Let's count. 1, 2, 3, 4. So 4 atoms of how many elements? Nitrogen element and hydrogen element. So of 2 elements. Okay, those are the 3 examples of the compound molecules. Okay, yes, let's complete lesson 3. Yes. Now let's go. Okay, lesson 3, which is the atomic structure of the matter. Okay, here in this table, you have to memorize the element symbols. And when you memorize them, okay, you can practice them. Just go to the Google, okay, open your browser and write quizzizz.com and then enter this code, okay? So you'll find 36 questions about the element symbols. So you can check your memorizing, okay? Okay, the atomic structure of matter. Okay, let's see the atom. This is the atom. The atom contains or consists of two main parts, the nucleus and electrons. Oh, yeah. Why the nucleus? It is positive charge. It is positively charged. Why? Because it contains what? It contains positive protons and neutral neutrons. So like positive and zero, so it will be positive. Okay, so the nucleus is positive charge. Okay, has positive charge. Okay, what about the charge of all of the atom in the ordinary state, in the normal state, all of the atom? So let's see here in the nucleus. Yeah, it has positive protons and neutral neutrons. Okay, so it's a positively charged particle. Okay, so here it's positive 2. And as you can see here, how many electrons? Oh, 2 electrons, 2 positive protons and 2 negative electrons. So the net charge of the atom is 0, or it's neutral. It's neutral. Why? Because if the atom has 5 protons, so sure it will have negative 5 electrons. If it has positive 10 protons, it will have negative 10 electrons. So the net charge of the atom will be uncharged, okay? It's not positive, it's not negative, okay? So the atom is electrically neutral because the number of protons equals to the number of electrons. Okay, the energy levels, yes, energy levels, those are imaginary regions around the nucleus where the electrons are revolving according to their energies. Okay, how many energy levels do we have? Let's start with K, L, M, N, O, B, Q, R, S, T. No, just Q. Finish. This is the heaviest atom. The heaviest atom contains 7 energy levels from K to Q. And as you go away from the nucleus, the energy of the level increases. Okay, so sure for this one, yes, Q has more energy than B, and M has more energy than L has more energy than K, and so on. Okay, what is quantum? What happened to you when you eat a bar of chocolate? You will jump upward, yes? What happened to you if you don't have energy? So you will fall, you will stay near to the ground, yeah? Okay, so what is quantum? Quantum is the amount of energy lost or gained by the electron when it transfers from one energy level to another energy level. How? Okay, this is an electron now, okay? The electron in its normal state will be in this state, in this level, okay? Okay, when it gains a quantum, a specific amount of energy, it will jump to higher energy level, like here. And the atom now, it's called excited atom, like you are eating a bar of chocolate. And when it loses the same quantum of energy, the same amount of energy, so it will return back to its original state again. Its original state, like when you fall down to the ground again, like here, okay? So the atom that gains a quantum of energy, we call it the excited atom, okay? Okay, for any element, we have two numbers. This number is the atomic number, which equals to the number of protons inside the nucleus. And this number is the number of protons and the neutrons inside the nucleus. And by the way, the mass of the atom is concentrated in its nucleus because the mass of the electrons are negligible. So related mass number, so it's the mass of the protons and neutrons inside the nucleus, okay? Why the mass number is usually greater than the atomic number? Why? Because the mass number equals what? Number of protons and neutrons, while the atomic number is the number of protons only, okay? And the only atom that its mass number equals its atomic number, it's the hydrogen atom. Here it has only one proton, and this number is the mass number, it's the number of protons plus neutrons. It has one proton, so number of neutrons, 0 neutrons. غلبان. Okay, so poor atom. Okay, so the mass number usually it's greater than the atomic number except for hydrogen only. Okay, here for this one, let's take those two rules that are very, very, very important. This slide, any exam should have questions from this slide, 100%, inshallah. 2n⁻² rule. When we use this rule, we use this rule to know how many electrons saturate the first 4 energy levels. So for the K level, it's energy level number 1. Okay, so let's calculate the number of electrons here. Yes, it's 2, and here is energy level number 1, so 2 times 1 power 2. So it equals 2 times 1, so it equals to 2 electrons. Wow, so the K level is saturated by 2 electrons. What about with the L level? Okay, again, apply the same rule. 2n⁻². Here is L is 2. So it's 2 times, this is L is energy level number 2. Okay, so here 2 times 2 power 2. Because n here, n is the what? The number of the energy level. Okay, so it equals 2 times 4, so it equals to 8 electrons. Yes, right. Yes, by applying the same rule to the M level, so it will saturate by 18 electrons, and N level, it will saturate by 32 electrons. Wow. Okay, can we apply this rule to the fifth, 6th, and 7th energy levels? No, we can't apply, because the atom if the energy level contains more than 32 electrons, it will be unstable. So the atom will be unstable. Okay, so we can't apply this rule more than the fourth energy level. Oh, yeah, but when we use the other rule, 28888, which is called octet rule. This is an old rule, okay? But we use it to know only if this element is chemically active or inactive. How, teacher? Okay, so let's make electronic configuration of both of those of those two elements. Okay, yes, this is potassium and this is argon. Potassium, it has here 18 protons. Yeah, this number again, let's remember again. Yes, this number is the number of protons. We call it the atomic number. Number of protons equals to the number of electrons in the neutral atom. So we have here 19 electrons. Let's distribute those 19 electrons in the energy levels. The first energy level will contain 2, then the second will contain 8, then the third will contain 8, then the fourth will contain 1 electron. Why, teacher, we didn't apply this rule? Because here we need to know, is potassium is chemically active or inactive? Oh, so how can we know? Let's look at the last energy level, the outermost energy level. It's not completely filled. Yeah, here N, it's completely filled when it becomes 8. So it's not completely filled, so it's active. It can share in chemical reactions. Okay, what about argon? Argon, yeah, how many electrons will we distribute? We'll make the electronic configuration of how many electrons? 18. Why? Because this is the number of electrons. Yes, it's number of electrons. It's the atomic number. This number is atomic number. Okay, this number is atomic number, which equal to the number of protons inside the nucleus, which equals to the number of electrons that revolve around the nucleus. Okay, so here we have 18 electrons. Okay, for the first energy level, K level 2, then L8, 2 plus 8, 10. We still have 8. Okay, so we have here 8. So 2 plus 8 plus 8. So here we have 18 electrons. Like that, we finished all of them. All of this number. Let's look at the outermost energy level. Yes, it has 8 electrons. 8 electrons, it means it's completely filled with electrons, completely filled with electrons. So it's inactive. It will not participate in the chemical reactions in the ordinary conditions. No, it's lazy. It's from the noble gases. Okay, guys? So we use this rule, 28888 and so on, to write the electronic configuration of the element. Why? To know if this element is active or inactive, okay? We can't write here 29 or 218, no. To know the activity, okay, the chemical activity, you have to make the octet rule. Now, let's start Unit 2. Yes, Unit 2, Lesson 1, Energy, Resources, and Forms. Yes, okay. Resources of energy. From where can we get energy? We get energy from the sun. Yes, it's a permanent resource. It's a permanent resource of energy. Yes, this is the sun. Okay, yeah, there are some resources of energy are called renewable resources. Like what? Like the movement of water and the movement of air, which is the wind. Oh, what about with the third one? Yes, it's non-renewable resources. Non-renewable resources, so they may finish after some time, okay? Like fuel, like nuclear reactions, and the food, okay? So again, resources of energy, some of them are permanent. The only permanent resource of energy is the sun, okay? Renewable movement of what? Of water and movement of air. Non-renewable, like fuel, nuclear reactions, and the food. What are the forms of energy? Yes, in the previous slide, we saw the resources. Now the forms of energy. Light, which we can get it from the sun or can get it from the electric lamp or from the kerosene lamp. Yeah, sound energy, we get it from the speakers or from the musical instruments. Or the third form, electric energy. We can get electric energy from the solar cells. Also, we can get it from the wind generator. Okay, we can, the first, yes, okay. Then we have here heat energy, which can be produced from the stove. All of these, light, sound, electric, heat, all of these are forms. We have other forms, yes. Yeah, chemical energy. Chemical is a form of energy. Yes, chemical energy, like the energy that is stored in what? Stored in the fuel, the energy that is stored in the battery. All of the batteries, except the solar battery. The solar battery, it stores electric energy, okay? Okay, it's in your curriculum like that. Okay, chemical energy also, that the energy stored in the food, okay? Okay, another form of energy, nuclear energy, and mechanical energy. What is mechanical energy? It's the sum of the kinetic energy and the potential energy. Okay, there are some important, very, very important rules and definitions in this lesson. Okay, what? Okay, work equals what? Work equals force times displacement. Potential energy equals weight times height. Kinetic energy equals half mass times speed squared. And by the way, for this one, guys, yes, let's remember. Here, potential energy equals weight times height. If the weight increases to double, so sure the potential energy increases to double. If the height increases to double, the potential energy increases to double, and so on. If the height decreases to half, the potential energy decreases to half. There is a direct relation between the potential energy and weight, also the potential energy with height. Okay, what about the kinetic energy? Kinetic energy, as we said, yeah, it equals to half mass times speed square. We can say that velocity square. Okay, so the kinetic energy, when the mass of the object increases to double, so sure the kinetic energy increases to double. When the mass decreases to half, also the kinetic energy decreases to half. There is no powers here. Okay, so there is direct relation, and as one increase, the other will increase with the same amount, double, triple, and so on. Okay, what about with the speed? If the speed increases to double, so like that increases to double, what happened to the kinetic energy? Yes, let's see here for this one, 4 speed power 2, so the kinetic energy will increase to 4 times. Okay, so if the speed increases to double, the kinetic energy will increase to 4 times. Why? Because there is a direct relation between kinetic energy, direct relation between kinetic energy and the speed square. Not only the speed is square. Okay, what happens if the speed decreases to half? So like that, 2, yeah, it decreases to half. Okay, power 2. So the kinetic energy, what happened to it? Okay, so let's put this power here. Yes, it will equal to v power 2. Okay, and here, yes, it's 4. So 1 over 4. So the kinetic energy will decreases to quarter. Okay. Okay, let's see those very important definitions. Yes, what is potential energy? Potential energy, it's the energy stored in the object due to the work already done on it. What is kinetic energy? It's the work done during the motion of the object, What is mechanical energy? The sum of potential plus kinetic. Okay. Yeah, for this example, this example is very important because it collected all of the rules of the energies in this chapter. Okay, let's start. Yeah, here a stone of 5 kilograms. Okay, so we have the mass here. Falls from height 8 meters. What is its potential energy and its kinetic energy in all of the following cases? Okay, and here you know that the G, gravitational acceleration, equals 10 meters per second square. Okay, let's start from the first point here at the starting point. At the starting point here, it's here for this one. Yes, for this one we have it's not moved yet. It doesn't move yet. Okay, this is the maximum height. The maximum height. It's 8 meters from the ground. Okay, let's calculate the potential energy. Potential energy equals weight times the height. But we don't have the weight, we have the mass. So you have to multiply the mass with acceleration due to gravity to calculate the weight, okay, to get the weight. So the weight equals mass times gravitational acceleration, which equals to 50 newtons. Okay, like that we know. Okay, the potential energy equals what? Potential energy equals weight times the height. The weight we calculated here, 50 times its height from the ground, yes, 8 meters at the starting point. Okay, so it equals to 400 joules. We here you can notice something, or you can know another thing that it doesn't mentioned in your in this problem. What is the, yes, in the maximum height, at the maximum height, the potential energy here equals the mechanical energy. So we can know the mechanical energy. What's the mechanical energy? It's 400 joules, okay? So at this point, we can get the mechanical energy, okay, for this point, which is 400 joules. Okay, but he needs here yes, the kinetic energy. The kinetic energy at this point, it doesn't move yet, yes? So the kinetic energy equals 0. Yes, kinetic energy at this point equals 0. And the mechanical energy, as we said, 400 joules. Okay, what about if it's in 4 meters from the ground? Oh, yes, so it falls till here, 4 meters in the midpoint here, 4 meters from the ground. Let's calculate the potential energy. Potential energy equals weight times the height. Okay, the weight doesn't change. Yes, 50 newtons times the height, it changes to 4 meters. This is the new height, so it's 200 joules. Oh, yeah, okay, it's okay. Yeah, we calculate the potential energy here. But what about the kinetic energy? Yeah, teacher, we know it. Yes, kinetic energy equals half mass times speed squared. But here we don't have the speed square. We don't have the speed. So there is another rule that by using this rule, you can calculate the kinetic energy. What is this rule? Yes, we know that the mechanical energy equals potential energy plus kinetic energy. Wow, yes, we know the mechanical energy, mechanical energy doesn't change. For the moving object, doesn't change. So the mechanical energy is 400 joules at any point. Here, 400 joules, here, 400 joules, here, 400 joules, here, 400 joules. At any point. Also, on reaching the ground, the mechanical energy is 400 joules, okay? So to calculate the kinetic energy, you have to use the other rule, which is the mechanical energy equals potential plus kinetic. So here the kinetic energy is sure it's 200 joules. And by the way, here guys, in the midpoint, as we know, here in the midpoint, yes, in the midpoint, the potential energy equals the kinetic energy. Okay, here for this, at this point, at the maximum height, the potential energy equals the mechanical energy. All of the mechanical energy was potential energy. Okay, what happened on reaching the Earth's surface? Oh, yeah. Is it difficult? No, very easy. On reaching the Earth's surface, the potential energy equals what? Equals 0. Why, teacher? Okay, so let's remember the potential energy equals weight times height. Okay, the height 0. 0 times weight, so sure 0. The potential energy equals here what? Equals 0. Okay. The mechanical energy equals, as we know, potential energy plus kinetic energy. So 400 joules equals 0 plus kinetic energy. So the kinetic energy at this point is 400 joules. 400 joules. So again, here in this one, again, at the maximum height, here at this point, the mechanical energy equals the potential energy. In the midpoint, potential equal mechanical. On reaching the ground here, all of the mechanical energy, it changed into kinetic energy. All of the mechanical energy, is kinetic energy, because the potential energy here is 0. Okay, so the mechanical energy equals kinetic energy. Okay. Okay, a lot of calculations. So, like your brain make error. Yes. Okay. Give reason. Why? Why when a person affects a wall by a force, he can do work? Yeah, why? Okay, so let's remember what is the work. Work equals force times displacement. Did this wall changes its place? No, it doesn't move a distance. No. So the displacement here is 0. So sure, the work is 0. Okay. Okay. So here, why? Because the wall doesn't move a distance. Okay. Yes, give reason. No change in the potential energy when the object moves horizontally. Okay, so let's remember, put the rule and you will easily know the answer. Okay, potential energy equals weight times height. The object moves horizontally. Horizontally, it means what? It means moves right and left, right and left. Okay, so does the height change? No, and it's the same object, so the weight didn't change. Okay, the weight doesn't change, the height from the ground doesn't change, so sure it's the same potential energy. Like if you have a desk here and you put your book on the desk, okay, you are standing here. Okay, yes. Okay, so if you are standing here and you push the book to this level, okay, both of them have the same height from the ground. Okay, and the same weight, the same book. Okay, so if the height doesn't change, the potential energy will not change. Okay, yeah, so the height, because the height doesn't change. Okay, what about the kinetic energy of the static object? If the kinetic energy of the static object equals 0, why? Let's remember, write the rule. Kinetic energy equals half mass times speed square. Yes, okay. If it's static, static means what? It means it's not moving object, not moving object. It means the speed 0, 0 speed, so the kinetic energy will be 0. So because the speed of the static object is 0, so sure, it's what? It's 0, okay? So the kinetic energy is 0. Let's go to, yes, okay. Now we've finished lesson 1. Okay, let's go to lesson 2 in unit 2, energy transformation. Okay, yeah, energy transformation. As we said in the previous example, we said that the mechanical energy of the moving object, it's a constant value. So let's apply it with the pendulum, simple pendulum. If we have a simple pendulum and you pull this pendulum to this height, okay, this is the maximum height for it, okay, the work that you did is stored in the pendulum in the form of what? In the form of potential energy. At the maximum height, the potential energy is maximum, okay, it will not move upwards again, okay, so the kinetic energy here is 0. Why? Because the speed is 0 at this point. When you release it, what happened? Yeah, the potential energy decreases. Why decreases? Because the height decreases. Yeah, see this one, it's height. Imagine this is the ground. Imagine this is the ground. Okay, this height from the ground. Okay, imagine this is like 1 meter from the ground. But here it will be half meter from the ground. And here it will be like 0.2 meter from the ground. So as you go downwards, what happened to the speed? What happened to the height? The height decreases. Height decreases, so the potential energy decreases. What about with the kinetic energy? Yes, as we move downward, the speed increases, so the kinetic energy increases. Okay, then it will move to the other side. But before it moves to the other side, tell me the potential energy here is what? The potential energy at this point, it's the minimum. Why? Because it's the minimum height from the ground. What about the kinetic energy? Kinetic energy here is the maximum. So quickly, it will move to the opposite side, to the left. Okay, till it reaches its maximum height. At the maximum height, the potential energy is maximum. Here, the kinetic energy equals 0. Why 0? Because here, it's the maximum, it's the maximum height. At this point, guys, it will not move upward again. So like it will stop a little bit, its speed will be 0 at this one. Its speed will be 0 at this point. Speed 0, so like it will stop a little bit, then it will back again. So here speed 0, so it means that the kinetic energy equals 0, okay? Okay, and then what happened? It will stop? No, it will move to the other side again. Okay, but as it goes from this point around the rest position to the higher point to the left, okay, tell me what happened to the potential energy? Yes, potential energy as we go up, yes, increases. What happened to the kinetic energy? From maximum to 0, so what happened to the kinetic energy? Yeah, moving, so it decreases. So here, guys, again, okay, as you move upward, so what happened to the potential energy? Increases. What happened to the kinetic energy? Decreases, okay? Okay, yes, let's go to the next energy transformation. By the way, yes, the movement of the pendulum looks like the movement of the swing, this guy on the swing. Yes, it's potential to kinetic, kinetic to potential, potential to kinetic, kinetic to potential. Okay, there's exchanging between the potential energy and the kinetic energy. As the potential energy increases, kinetic decreases. If potential increases by 100 joules, the kinetic energy decreases by 100 joules, and so on. The increase here equal the decrease here. Okay? Okay. Yeah, here for the energy transformation from chemical to electric. All of these changing from chemical energy to electric energy. Yeah, inside the lemon there is an acidic juice, and inside the potatoes there is a salty solution. Okay. And here we have diluted sulfuric acid. There are some chemical reactions that happen inside them. And if we put two types of metal plates here, two different metal plates here, like zinc and copper, the electric current will pass. If this electric current causes a deflection of the needle of the compass, okay? And here the electric current will move from in the passage of electric current in the wire from the copper, the positive copper rod, to the negative zinc rod. Okay, let's say the energy transformation in the car. Okay, the energy transformation in the car. First, you go to the car station, you put some fuel inside the car. The fuel stores chemical energy. This chemical energy changed by burning into thermal energy. Then quickly, قبل ما العربية تولع, quickly to mechanical energy. There is a port. Okay, so now till mechanical energy, the car can move. Okay, but we need to lighten the lamps of the car. We need to use the AC of the car and so on. So there is another device in the car that is very important. It's called a dynamo. Dynamo, or we can say it's electric generator. It changes a part of this mechanical energy into electric energy. Then change this electric energy into light energy, or to the sound energy, or to the heat energy. Okay, dynamo is very important to change a part of mechanical to electric. Okay. We have, okay, so can we create energy? No. Can we destroy energy? No. This is called the law of conservation of energy. Energy is neither created nor destroyed, but it can change from one form to another form. And the changing of energy from one form to another form, people use it to make some technological applications. These technological applications have some positive and negative effects on the environment. So let's see the positive effects on environment. Like we use the energy transformation in making the sewing machine. Sewing machine changes the electric energy into mechanical energy. The solar cells, it changes what? It changes the energy from the sun, the solar energy, to what? It changes to electric energy. Okay, what about the negative effects of using technology? Like some technological application cause electromagnetic pollution. Electromagnetic pollution because of what? Because of using the wireless transmitters of the cellular phones. So don't use them a lot. And so don't sit beside the router or the wireless transmitters for a long time. Okay. The second negative effect is the noise pollution. Yes, loudspeakers, drilling machines, they cause noise pollution. The third negative effect, they cause chemical pollution. Chemical pollution of what? Chemical pollution of air, of water, and of the soil. Like what here, guys? Like the chemical pesticide. Using the chemical pesticides, it causes chemical pollution. So when you see a mosquito, take care, okay? Spray it with very little amount of this pesticide. Don't say, psh, 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 psh. No, okay? Because it may hurt you. Okay, yes, now let's go to the next lesson. Yes, the next lesson, which is the heat energy, and this is the last lesson here in unit 2. Okay, heat energy. What are the sources of heat energy? A lot of sources of heat energy. Between those sources, the sun. Okay, and what is a friction? Wow, yes, what happened when you are so cold in winter? So what happened? Yeah, you wrap your hands. Wrapping hands, it changes the mechanical energy into heat energy. Also, a friction between this box and the floor, it changes the mechanical energy into heat energy. Oh, so what is the heat energy? Heat is a form of energy which is transferred from the object of higher temperature to the object of lower temperature. So imagine if we have here two solid material or two solid objects, yes? Yeah, here is A and here is B. And A, it's 80 degrees Celsius, B is 50 degrees Celsius. Oh, yes, the heat will transfer from A to B, from the object of higher temperature to the object of lower temperature. Temperature. So what is temperature? Temperature is the heat condition which determines the direction of the heat from the object, or to, okay, or to the object, when the two objects are close together or come in contact with each other, okay? What are the ways of transferring heat? Okay, the heat can transfer by conduction, so through solids. Solids, the heat transfer from the part of higher temperature to the part of lower temperature by conduction. What about the liquid and gases? Liquid and gases, the heat transfer in these media by convection. How, teacher? The hot molecules have high density, so they will fall down. Okay, what about the hot molecules? Hot molecules, they have low density, so they will float, okay, and move up. Okay, move up and move down, move up and move down. This is through gases and liquids, okay? The transferring of heat by radiation, it's the way of transferring heat. If there is media, if there is gas, okay, it will transfer through it. Or if there is nothing, space or vacuum, also the heat will transfer by radiation. So transferring of heat by radiation, the heat is transferred through material media and non-material media, okay? Why the freezer of the fridge is found at the top of the fridge? Why the freezer is here? Okay, let's look at this picture and decide. Yeah, here for this one, guys. Yeah, the heat, the cold air here in the freezer, it has high density or low density? Yes, it has high density. So it's has high density, so it falls down to cool the food inside the fridge. What about the hot air inside the fridge? Hot air, it has low density, so it will move upward to the freezer to be recooled again and again. Okay. Why the heat of the sun doesn't reach the earth by conduction or convection? Why? What is the thing that's between the sun and the earth? First, guys, yes, there is no material media here. Here, between the sun and the earth, in this part, yes, there is a space. There is vast space. There is nothing here. You know that the Earth is covered by atmosphere. Okay, yes, this is the atmosphere that covers the Earth. Okay, but what about the space between the sun? Nothing, vacuum between the sun and the Earth. Oh, so the heat transfer from the sun to the earth by radiation, because there is no solid, no liquid, no gas to transfer through it here, okay? So because there is a vast vacuum or vast space, very large space between the earth and the sun. Okay, let's see, the solar energy changes into what? Solar energy can change into chemical energy. In what? In the plants during the photosynthesis process. Okay, yeah, we eat plants, we eat food. We said before that the food stores chemical energy. From where this food stores this chemical energy? From, yeah, the photosynthesis process that the plant did it before. Okay, and also chemical solar energy to chemical energy in the which is stored in the petroleum oil. Okay, fuel, as we said before. Okay, here for the heat, solar to heat energy in the solar furnace and in the solar heaters. What about the changing of solar energy to electric energy? And it comes a lot in the exams. Yes, solar cells and solar batteries. Solar cells and solar batteries, they are examples of changing the solar energy into what? Into electric energy. Okay. give reason why the developed countries في أمريكا والدول المتقدمة why the developed countries aim to use the solar energy more than before. Solar energy, it depends on what? Depends on the sun. Sun is a permanent resource of energy. It's cheap and clean. It doesn't pollute the environment. So sure, they love using solar energy more than the non-renewable energy resources. Oh, teacher, we finished? No. Did we finish? No, we didn't finish yet. Wake up! Still unit 3. Love you so much. Now it's unit 3. Yes. Okay. Living organisms diversity and the principles of their classification. Okay. Let's go to lesson 1 in this unit. What are the microorganisms? Microorganisms. Okay, first, all of this unit, it talks about the biology. Okay, the biology. Okay, yeah, here microorganisms. Microorganisms are very small living organisms. Can we see them by our naked eye? No, we can see them by our naked eye, but they spread everywhere in air, in water, and in soil. We have 3 examples of the microorganisms: amoeba, which moves by pseudopods, euglena, which moves by flagellum, and paramecium, which moves by cilia. The microorganisms differ from each other in their shapes and in their way of movement. Okay, let's make the classification of plants. Classification of plants according to first the appearance, their external appearance or their external shape. We divide them into 2 groups. There are some plants that can be distinguished into roots. Yes, I can see the roots, I can see the stem, and I can see the leaves. Like what? Like the maize plant. There are some plants that we can distinguish between the roots, stems, and leaves. Like what? Like algae. All of the algae, we can differentiate between its roots, stems, and leaves. Look at them. Yes, very, very, very small. So from the external appearance, we can differentiate between the first 2 groups of plants. Okay, classification of plants, but now according to the way of reproduction. There are some plants that reproduce by formation of spores. Their babies are called spores, like what? Like voyeur and like adiantum. There are some plants that reproduce by formation of seeds. Their babies are called seeds, but those seeds should be covered by what? If they covered by a pericarp, so we are in the group of angiosperms. Or if they are covered by a cone, so they are gymnosperms. Angiosperms, we divide them into 2 groups: monocotyledon, dicotyledon. Monocotyledon, the seed has only 1 cut inside it, like what? Like maize and wheat. Dicotyledon, the seed inside it, 2 loops or 2 cuts, like what? Like beans and peas. Okay, monocotyledon or dicotyledon, all of their seeds are inside pericarp, so we call them angiosperms. What about the gymnosperms? Their seeds inside cones, like pine tree and cycas plant. Okay, the classification of animals. Okay, classification of animals according to the nature of the body support. There are some animals that they are soft-bodied animals. They don't have any body support, like jellyfish, like octopus, and earthworm. There are some animals that have supported bodies, like what? Like, oh yeah, first, these animals, a lot of animals that have body support, but according to the where or according to the location of this body support, we divided them into 2 groups. The group of animals which have external support, like mussels and snails. Do you know, Turbo? Yes, this part is the shell. This is outer its body. It covers its body from outside, so it's external support. What about the animals that have internal body support? Yes, we, the human, we have internal support. We have vertebral column. All of the vertebrates here, all of the fish, cows, reptiles, birds, amphibians, all of these have internal body support. There are some animals that have internal and external body support, like what? Like the turtle. Yes, see the aquatic turtle? Yes, this is the internal body support, and this is the shell, which is the external support. According to the number of legs, we divide the arthropods into groups. But what are the arthropods? Arthropods, they are invertebrates. They don't have vertebral columns, and they have jointed legs. Oh, so we divide them into 3 groups: insects, arachnids, and myriapods. Insects, they have 3 pairs of jointed legs, like ants, like bees, like flies. Arachnids, they have 4 pairs of jointed legs like spiders and scorpions. So why? Give reason. Why? Why we didn't consider spider from the insects? Because the spider, it's related to arachnids. Yeah, it has 4 pairs of jointed legs, while the insects have 3 pairs of jointed legs only. Okay, what about the myriapods? They have numerous legs like Scolopendra and Julius. Okay, according to the number of teeth, we divide the mammals into groups. There are some mammals that don't have any teeth. Yeah, so poor. Like what? Like sloth and armadillo. Sloth and armadillo don't have any teeth. Do you know, Dave? Yes, it don't have teeth in the real life. It doesn't have teeth in the real life. Mammals have teeth. Most of the mammals have teeth. Those mammals don't, the only mammals that don't have teeth, here sloth and the armadillo. This is in your curriculum, okay? The mammals that have teeth, according to the number, the size, and the shape of their teeth, we divide them into groups. Some mammals have teeth that are extending outward. Like what? Like the hedgehog. Why? To capture insects. Some animals have pointed canines with molars with sharp, and their molars with sharp projections, like what? Like all of the carnivorous animals, lion, tiger, fox, and so on. Okay, according to again the number, the presence of teeth, and the number of teeth, and the number of incisors, sharp incisors, we divide some animals into groups. The rodents and lagomorphs. Rodents, they have 1 pair of incisors, of sharp incisors in the upper jaw and 1 pair in the lower jaw, like what? Like rat, jerboa, and squirrel. Lagomorphs, it's a group of mammals that has 2 pairs of sharp incisors in the upper jaw and 1 pair only in the lower jaw. We have here only one example, which is the rabbit. Okay, give reason why it's possible to produce a fertile offspring. Those are the fertile individuals, fertile offspring from mating between African men and Asian women. So here we have African men and here we have Asian women. If they marry together, okay, so their kids can marry again and they can have kids again. So their offspring is fertile. Why? Because they related to the same species, What about if there's intercourse happen between donkey and the horse? Donkey and horse, yes, if they reproduce, they will produce a sterile offspring, a sterile mule, because both of them have different species. Okay, let's go to the last lesson. Yes, adaptation and diversity of the living organisms. Adaptation. We have 3 types of adaptations: structural adaptation, functional adaptation, and behavioral adaptation. Okay, what is adaptation? It's a modification of what? In behavior of the animals, or in biological functions, or in the structure of the body organs. Why? To help the animal or the living organisms to cope with its environment, okay, or with its environmental conditions. Okay, for the mammals, all of the mammals, they have similar limbs, similar bones of limbs. Oh yeah, the dog or the horse, its front limbs are modified into legs. Oh, for the bat, its front limbs are modified into wings. For the gorilla, for the monkeys, their front limbs are elongated. Why? To help it to catch things and to climb the trees. Okay. The front limbs of the whale, sea lions, they are changed or modified into paddles. Okay, so all of the mammals, they have similar limbs. They have similar bones of limbs. See, teacher, is the bat a mammal? Yes, it's a mammal. And let's look at its arms. Yeah, wow, look, it modified into wings to help it to fly, but it still have 5 fingers like you. It has rib cage like you, and so on. All of these types of adaptations here in this slide is which type of adaptation? Structural adaptation. Type, so you have to mention structure, function, or behavioral. The structure of the body organs changed, so it's a structural adaptation. Okay, what about with the birds? There are the birds, they live in different environments, and also they feed on different types of food. Okay, that predatory bird, they have strong sharp crooked beak. Why? To tear meat. What about their legs? They have 3 anterior fingers, and with 3 anterior bendable fingers and 1 posterior. 4 bendable fingers, 4 bendable sharp fingers, and with sharp claws. Why? To help it to pounce catching the prey. Okay, 3 anterior and 1 posterior. What about with the birds that feed on worms and snails, like heron and hippo? They have long, thin beak. Why? To pick up worms. Yeah. What about its legs? Long, thin also. Why? To help it to walk, because it walks in water, not swim in water. What about the water birds, like the ducks and geese? Ducks and geese, they have wide indented beaks in 2 sides. Why? To filter its food from the water. What about its legs? It has palm legs. Why? To help it to swim in water. Okay. The insectivorous plants. Insectivorous plants. First, the plants do photosynthesis process. Okay, so let's change the color. Okay. The plants do photosynthesis process. The plant do photosynthesis process. Okay, the plants use carbon dioxide, water, okay, and in the presence of the solar energy, okay, so they will make carbohydrate, okay. So the plants take the carbohydrate, don't absorb it from anywhere. The plants can make their own food. So we say that the plant is this plant is autotrophic. Auto means self. Auto self. Trophic means feeding, self-feeding. Why they are self-feeding? Because they can make photosynthesis process to make carbohydrate. Okay, so those plants, they bounce insects or they trap insects. Why they trap insects? Why? Because the plant, most of the plants, their roots inside the soil, their roots absorb the nitrogenous substances from the soil. Okay, their roots absorb the nitrogen substances from the soil. But what about with the insectivorous plants? Insectivorous plants, their roots can't absorb those nitrogenous substances from the soil. So how can those plants become healthy or make protein? How can they make protein? They can make protein by pounce insects, by trap insects and digest them, then take the nitrogenous substances from their bodies so they can make protein. Okay, so those plants, bounce insects, Dionea, Drosera, and Alophila, those plants bounce insects. Why? They bounce insect to absorb the nitrogenous substances from them, then they can make protein. What's the type of adaptation is it? This is what? This is structural adaptation. Structure of the organ changes. Okay. And now let's see some examples of the adaptation. Hibernation. Some animals become dormant during the winter. Why? To avoid the very high temperature, to avoid the decrease in temperature, the very low temperature. Those animals, like what? Like reptiles, like some insects. The same. Why the frogs or toads, they put themselves in mud in winter? Why? Also to overcome the decrease in temperature, the very low temperature in winter. Okay, what about with the estivation? Estivation looks like hibernation because it's a behavioral adaptation also. It happened in a specific time of the year. Why animals do estivation? Some animals do estivation also to overcome the very high temperature. So for estivation, some animals, to overcome the very high temperature, they estivate. But for the hibernation, some animals become dormant and stop most of their vital activities in winter. Why in winter? Because they want to overcome the decrease, to avoid the decrease in temperature. Okay, we have 2 examples of hibernation, which is 3 examples. We have reptiles, some reptiles, some insects, and frogs. Okay, in estivation we have 2 examples only, jerboa and desert snail. Okay, What about the birds migration? Birds migration is an inherited behavior, something in their genes. Okay, it's an inherited behavior through which the birds they migrate from cold and polar regions to more light and warmer regions. Why? Why these birds do that? To search for more warmer and light place for reproduction. They reproduce, raise their chicks. Then, when the environmental conditions become favorable, they will return back to their homes again. Okay, this type of adaptation again is which type? It happened in a specific time of the year, so it's behavioral adaptation. So migration, hibernation, and estivation, all these three forms of behave. This is all of the three, yes, they are behavioral adaptation. What about the camouflage? Camouflage, camouflage, it's the adaptation of hiding. Like here, this is the leaf insect, this is the stick insect. Wow, this is the chameleon. Yeah, okay. The leaf insect, it's a type of adaptation, is a structural adaptation. The body structure changes. Yes, organ or more than organ changes. Also for the stick insect, the same structural adaptation. But for chameleon, it's a functional adaptation. Why it's functional adaptation? To do specific function. Then it will return back to its original color again. Okay. So there are some animals that can color themselves by the dominant color of environment. What are those animals? The chameleons. Chameleon color itself by the dominant color of the environment. Why? To hide from its enemy. Then quickly they can capture its prey quickly. Okay, the camel is the desert shape. It has all of the types of adaptations, and like that, we finished. Alhamdulillah. Good luck in your exam, and thank you so much. See you soon, inshallah. We finished all of the curriculum. Thank you so much. I hope you understand everything. I hope you revised everything. Thank you.